Okay, P11.2 pressure in a liquid at rest. Okay, so the first thing I'm going to do is I'm going to show you a little picture that will hopefully help you to make more sense of this topic. So if you imagine a container that's filled up with water and you drill a hole in it and the water comes out, and then you drill another hole in here, but this water goes further, and then you drill a hole here, and this water goes even further. So why is it that that water goes three different distances? Well, we know that the rate at which it's being propelled out of the canister depends on its pressure, so we know that as the height of the water above it increases, the pressure increases. Okay, it's why dam walls are built like this, because if they've got to stop the water, it makes a lot of sense to put most of your concrete down at the bottom where the pressure is greater and very little at the top where the pressure is a lot less. Okay, so let's look at the maths behind that. Let's look at why that might be the case in terms of maths. Okay, so we know that pressure equals force divided by area. Okay, we're happy with that. We know that pressure equals force divided by area. So if you imagine that you've got a beaker here and you've got at the bottom of the beaker, you want to know what's the pressure of this water above it. Okay, so you know that it's the area of the beaker, that's the force of the water pushing downwards divided by the area of the beaker's base. So we're happy that that's F over A. Now we know that the F is the weight of the water, so we know that that's equal to the weight divided by the area. We know that the weight is equal to mass times by gravity. Okay, and we know that mass is equal to the volume times by the water's density. And if you remember from density, we're going to continue to use that simple rho. And we know that that is going to be the height times by the area times by rho. Okay, which means that if I just substitute this back into this, that gives me P equals HA rho G. I've got that G from this bit here, all over A. And if you've got something on the top that's the same as something on the bottom, you can just cancel it out, which tells me that P equals H rho G. So that tells me that the pressure at the bottom here doesn't depend upon the area. I could make that tank as wide as I want. The pressure will still only depend upon the height of the water above it. And that's because pressure also depends upon area, and the two areas cancel each other out, which is quite handy. So you can know what pressure anything's going to be at any given height, regardless of where you are, simply by using rho GH. That's it.